So, many of you may be wondering what an opposition is. Well, the clue is kind of in the name. When Neptune is at opposition, it's positioned opposite the Sun in our sky. So basically, at sunset, the Sun's behind you, Neptune is rising in the east off the other horizon. So the planet's therefore visible virtually all night long. And as I say, it rises as the Sun sets and is setting in the west at sunrise. Now, opposition is also when a planet's apparent size is at its largest, and it's the best time to observe any planet. But well, Neptune is then the furthest planet in our solar system, and has been for 10 years since the poor little Pluto was kind of deplanetized. But how far away is Neptune, and how can we put that kind of into a human perspective?
Yeah, Neptune's, we could say it's 2.7 billion miles away, or in terms of Earth-Sun distances called the astronomical unit, it lies 30 astronomical units away. It's so far away that light takes hours to get there, so far away that the solar wind, by the time it gets to Neptune's vicinity, has thinned out and spread apart so that it actually is a safer environment than astronauts would have around here.
And Bob, if we tracked most exterior planets, so Mars beyond, if we track them in the same field of view in a 24-degree field like this, we'd actually see them looping, wouldn't we, in the sky, or appearing to?
Quite so, and that's because the planets have an inclination to the flat plane of the solar system defined by the Earth-Sun orbit. For example, Neptune, if I remember right, has a 1.77 degree inclination to the plane of the ecliptic. Mercury's is 7 degrees, Venus is 3.4. And because of these little tilts, it means that as we're passing them and as we're moving, they don't just move forward and back as we pass them, as if we're overtaking a slower moving truck on the highway. It means we're above them or below them, and so we're seeing loop-de-loops and curlicues and all sorts of motions that actually drove the ancient observers berserk as they were trying to figure out what was really going on.
Neptune is popularly referred to as an ice giant, and even Astronomy magazine uses that term sometimes on its cover from time to time. But I know in the past you've disputed that term, on previous shows. Why do you think that that's not a particularly appropriate term for either Neptune or Uranus?
Compared to those first two of the giant balls of mostly gas, hydrogen and helium, Uranus and Neptune have more what's called ices. They're really water, ammonia, methane, and we don't think of ammonia or methane as real ices. And in fact, as you go down deeper and deeper, it's true these things contain more of these substances, and planetary scientists do call them ices, but in truth, they're mostly in a liquid, warm, hot, or slushy form as you get lower and lower. So we shouldn't really think of ice as if we're going on a skiing vacation somewhere. Nonetheless, there's the term, and as long as we understand that the real distinction between Jupiter and Saturn is that these things have more water, methane, and ammonia. In fact, it's the methane that makes Uranus look so blue, because methane absorbs the sun's red light and reflects the green and the blue. Then we're fine. It's fine. It's a fine term.
But why haven't we ever sent a spacecraft mission to orbit Neptune to study it further? Do we think it's boring? And do you agree that with the fact that we haven't done so?
And only Voyager 2 went beyond as almost an afterthought. Yes, we'll visit Uranus in 1986, January of that year, and then Neptune, but it was almost thought to be expendable. So we're lucky to even have these. Should we go back? Of course. They're expensive, these missions. But before we talk about manned missions there, we've got a long way to go. We haven't even gotten to Mars yet, and then we've got some of the moons, especially Ganymede of Jupiter, that's outside Jupiter's fearsome, lethal magnetosphere. So we could safely go to at least Callisto. That's well outside the magnetosphere. That's the safest place. And then Saturn has its own moon system. And then Uranus has some fascinating moons like Miranda in particular, where we'd want to do geology. So when we're talking about Neptune at 30 AUs, boy, I mean, that's the distant reaches. From there, the sun is 900 times fainter than it is from here. That's far away.
But a lot of people don't know that while Voyager 2 was flying past Neptune, the images it beamed back revealed that Neptune 2 has rings. So what do we know about those, Bob? And is it possible to, as an amateur, to observe this? Isn't there something you can do if they transit in front of a star?
Not really, no. These are very, very skimpy things. You know, we call them rings, but they're more like fragments and more like arcs. They look like complete rings here, but they're very, very flimsy and skimpy. We hate to give them the full credit. You know, it's like here in New York State, there's a place called Leechmere State Park, and it's advertised as the Grand Canyon of the East. Well, you know, honestly speaking, it's not the Grand Canyon.
Okay.
And similarly, those magnificent rings of Saturn are really not duplicated elsewhere in the solar system. The others are just little tiny flimsy fragments. And no amateur telescope can hope to see it.
Earlier, what makes Triton's orbit so unique among the other moons in our solar system?
It is the only major moon that orbits backwards instead of going in the normal counterclockwise direction, which is all major moons as seen from north of the solar system look like they're counterclockwise. This one is the wrong way. It's a retrograde orbit. It has to be captured because everything else in the solar system essentially is one way. So it must have been a captured object, probably from the Kuiper Belt. But if it's captured, how the heck does it end up with one of the most perfectly circular orbits in the entire solar system?
Ooh, hadn't thought of that.
If I remember its orbital eccentricity, it's 0.0000016. It's indistinguishable from perfect circles. So a little odd that it should end up with that kind of a perfect orbit being a captured object, but it does.